Welcome back. So now we're going to dive into real world examples, real world problems, because there are many real world scenarios that you talk about a percent growth or percent decrease over time. And so we're going to model that with exponential growth and exponential decay. So the two equations you're going to need to know. That growth equation, and again, growth makes sense because there's a plus there, and your exponential decay, which again should make sense because you have your minus there. So that's really the only difference between these two equations. If you can remember the basic structure, which is your starting amount, then 1 plus or minus your rate to the power of the amount of time you're talking about, well, then you're going to be able to figure out what it is. So again, A is the initial amount, how much you're starting with, and R is the rate as a decimal. So there's a couple steps to doing this. The first thing, one important thing about this one is realizing the vocabulary that it takes. All right, so there's vocabulary that will help identify it as growth or decay. And I need you to understand that vocabulary and be able to identify it because you have to pick which equation to use. Once you've identified that, you want to find A, the initial value, and R. Now, one thing about R is usually in these problems, it will be given as a percent. We can't use percents in an equation, so you're going to have to turn it into a decimal for me. Then you're going to plug everything into the equation and solve. So, let's dive into our first example. A car loses value as soon as it is purchased and driven off of the lot. You buy a new Ford sedan for $12,400. If it depreciates in value by 11% per year, how much will it be worth in 5 years? The vocabulary that I'm going to focus on is talking about losing value and depreciates. All right? That's going to communicate to me that we're talking about an exponential decay problem. All right, so we're going to be modeling something that looks like that. All right, this is going to be a decay situation. Now, the next thing we need our A. So we need to know what is our starting value. Well, here our starting value is 12,400. And we need our rate. Well, our rate is going to be 11%. But again, we can't use it as a percent. So you have to take that decimal place there, move it over twice. So instead of 11%, we're going to be using 0.11. Okay, you need to turn it into a decimal. And now I'm going to plug that in. So 12,400, 1 minus 0.11 to the t. Well, 1 minus 0.11, that's just going to be 0.89. So here is my equation, 12,000 times 0.89 to the t. Now, to actually answer the question, there's one more piece of information that we can use. We can use the fact we're talking about 5 years. So my t is going to be 5. So now I have everything I need to find out my amount. So I have 12,400 times 0.89 to the 5th power. All right, and that's what I'm going to plug into my calculator. And if you plug it in carefully, you can just type in the whole thing at once. So 12,400, oh, one too many zeros, 12,400, then in parentheses 0.89 to the 5th power. So you can actually type the whole thing in at once. Hit enter, and there you go. $6,924.23. So going to go back to my other slide, and that is going to be my answer. And here we're talking about money, so I'm going to put a label of money. And when you're dealing with money, remember you want to go to 2 decimal places. All right, let's try another one. Cell phone use has been increasing rapidly for high school students. A recent study showed that this year 1,560 students at Elk River High School have cell phones, and it is increasing at a rate of 4.7% per year. How many students will have cell phones in 6 years? All right, so the first thing I want to do is identify vocabulary. I see the word increasing. So increasing means we're going to use our exponential growth model. So that's going to be the structure of my equation. I need my initial amount. Well, it says currently 1,560 students have cell phones. Then I have the rate, 4.7%. But to change that to a decimal, I move the decimal over twice. That's going to be 0.047. One thing to remember with these decimals is making sure you use that placeholder 0 when you need to. But moving it over twice this time, I need that 0 there. So right now, that's going to give me 1,560. 1 plus r. 1 plus 0.047. Well, that's just going to be 1.047 to the t. And now we're talking about in 6 years. So my t is going to be 6. So what I want to plug into my calculator is I'm going to plug in 1,560, 1.047 to the 6. All right, so let's go and type that in. 1,560 times 1.047 to the 6th power. That's going to give me 2,054.966, blah, blah, blah. Well, here we're talking about people, right? We're talking about number of people that have cell phones. So when we're talking about living things, it makes sense. We're going to want a whole number, right? We don't want parts of people. So I'm just going to round that to a nice even 2,055 students will have cell phones. All right, moving on to our next one. Miami, Florida has reported record numbers in their growing population, a growth rate of 5.6% per year. The population of Miami is 86,400. If this trend continues, what would the population be in 10 years? All right, so first we're talking about a growing population. So we're going to use an exponential growth model. So we're going to use that as our skeleton. They're starting with 86,400 people right now. And then their rate is 5.6%. But again, we can't use a percent, so I'm going to have to move that decimal over twice to get 0.056. So that's going to be 86,400. 1 plus 0.056 will just be 1.056. Just add 1 to the rate, to the t. And now, in 10 years. All right, so 10 years. So what I'm going to type into my calculator, 86,400, 1.056 to the 10. Let's see what we get when we plug that into our calculator. 86,400, 1.056 to the 10th power, and we get 148,898. So 148,890. Oh, just want to make sure I write this down properly. 989. I apologize. 989 people will be living in Miami. All right. The wolf population is said to be declining in northern Minnesota. In 2001, a study was done and they noted 1,486 wolves. If their population is decreasing by 3% each year, how many wolves will there be in 2025? All right, so we're talking about a declining population. So declining population means we're going to use our decay model that looks like this. Once we've decided that we're going to use a decay model, we need to identify how many there are to start. So A is 1,486. The rate, which is going to be 3%. If you move that decimal twice to turn it into a decimal, that's going to be 0.03. So A is 1,486. 1 minus R. So 1 minus 0.03 is 0.97 to the T. Now, it says we took this information in 2001 and we're projecting to 2025. So that means 24 years have passed. So because of that, our T is going to be 24. If you're given 2 different years, you subtract those, find how much time has passed. Here, 24 years has passed. So that's going to be the T that we plug in. So I come over to my calculator. 1,486.97 to the 24th power. And again, rounding to the nearest whole number, we're talking about a living creature. That would be 715 wolves. All right, so that's going to be the end of these notes. So once again, make sure you have all this written down, and then please come and see me if you still have any questions.